All right, thank you. So we'll be looking at the second part of operating systems and Linux lesson today. Um, we're going to go over, we're going to go more in depth into process management, we're going to go more in depth into memory management by the operating system, by an operating system. What's an operating system does, and how it handles processes and memory. That will be specifically looking at the functions of the CPU videos, functions of the RAM videos. And then after that, we are going to then go into looking more into Linux, um, particularly on user management, group management, which is also part of it, and file connectors. After that, we look at some of the processes that we can use to control and manage some of the commands you can use to control and manage processes running on a computer, specifically in the Linux operating system, right? Okay, so let's begin. Um, yeah, so first of all, with the operating system part, then we go over to the Linux part. So looking at processes, we know that a process is a program in execution. A program is a set of instructions written in a file, written to a file. Executing that program creates a process that is an operating system needs to now manage and, and pass on to the processor to run and execute the instructions and the tasks that are written in the command in the program, which is now running as the process. The process is simply understood as a program that's operation of the execution. And there are different sections um, of a running process. We have the stack, which contains the data and the functions, the methods, the return address, and the local variables of the program as written on the program code and the file. Then you have the which is the memory that is allocated dynamically. That is say that it is not an absolute limit. It's more like a memory that is dynamically, not statically, but dynamically allocated to a process for its execution. Then you have the text, which consists of all the ongoing activities of the process, including the process pointer and the uh, register, the things that track the status of the process, and then the global data and global variable for the process during its execution, right? Then um, you can look at the sections of the running process as in this kind of structure where you have the start, you have the heat, you have the data, you have the text. And this is executed by the operating system. So going into the life cycle of the process, when the process is running, operating system, what are the various stages that the process goes through, the various steps that the process, a program has on a computer on an operating system. And this is the basic um, on look on what the steps would be like. It's going to be different from every for every operating system, which is it's going to look different for Linux. It might look different for Windows, but it would follow this process where you have the start, where you have the start of the process, which is the initial stage of the process when the process is started and kicked off. And you have where the process is now in a state where it is ready to be picked up by the processor and that is what we know as the ready state. Then you have when the processor begins to run, we work on the instructions and execute the instructions now. Um, had specified in the process of the program. That is the running space of the process. Now, when you come into an environment of multi-programming and multi-processing, where a processor would need to be handling more than one process, and you see that an operating system needs to have a way to schedule a process, put a process in, and move between various processes that a processor needs to handle. Um, when a process has started and has started being run by by a processor, but it needs to wait for some resource or some data, maybe user input or access to a file or access to a certain device or output or input device. Instead of the processor waiting for that operation, for that resource to be gotten by the particular process, it puts the process in a wait state and moves on to another process while this process gets what it needs. So that is what we understand by the wait state, the process being in the wait state. And then finally, when the process has either finished its execution or it needs to be stopped for whatever reason by the operating system, that's what we know as terminated or executed. That's the final stage of the process life cycle, the final stage of the running process life cycle. Um, so we see that the process begins from the start state and goes to the ready state. And it can stay in the ready and running and wait state until it finishes its execution or its scale. And then it can then move to the terminated state. Now, in an operating system, there's something we understand more of the process control block, which is a data structure for every process where that contains all the information on that process. And this is what the operating system uses to monitor and track the process while in execution and have all the data on the process so that um, can manage the process. The process control block has data such as the process ID, which is a unique identifier for that particular process. You see it mostly referred to in limits of the PID. You see, we have the process states, which we just went through. This is going to be constantly updated by the operating system, depending on the states, depending on the state of that the process is at a particular time. So you have the process ID, the process states, the process privileges, which speak to the different access levels that the process has. What is kind of access in files, devices, what access and what is kind of access. So the process has its own privileges. It has a pointer, which serves as the address field to a particular place in memory. It has the process counter, it has process registers, scheduling information, memory management information, accounting information, and input status information, and some more depending on the operating system and what information the operating system is keeping record of regarding the particular process. So to look more into that, we can see the process state, which is the current state of the process at a particular point in time, whether it is running, waiting, whether it is running, waiting, ready, executed, terminated. The process privileges, what the process is allowed or not allowed to access with regard to the people resources, with the system resources that is keeping memory, that can access, what level of access that it has. The process ID, which is the unique identifier for the process, so that if you need to access and use perform some commands on a particular process, that's it for you. The process the operating system needs to refer reference a particular process. It can do that through the process ID. The pointer, okay, the pointer is the reference to the parent process. So a program when run can create multiple processes, either as running together horizontally or vertically as its children. So it can have a process, maybe a calculator process that needs to have different child processes depending on the kind of calculation you need to perform. These different children processes need to be able to point and reference their parent process so that it can work together and pass information right back up to the parent's process after they perform their specific execution. So the pointer helps them to point and reference their parent process. Then you have the process counter, which tells that the pointer to an address to the address for the next instruction to be executed. If it's a sequential, if it's a sequential type of execution of concurrence, you need a way to point to the next instruction in the process, in the program. Um, and you need a way to point back to the parent process. So that's what the pointer and the process counter can do for you. We have the CPU registers, which serve as the different registers where processes need to be stored for execution during the RMA switch. You have scheduling information, processes work with schedulers, and operating systems rather work with schedulers, which handle things like yeah, priority, which is which states which process should run before which one, and which one should run. It's more important to run at a particular point in time. Hello, can you hear me, Adedeji?
Yes, I can. I can, sir.
Is it clear?
I can hear you, sir.
Okay, okay. I'm just
I
making
can
sure
hear
that
you, sir. Yeah.
my voice is clear. Okay,
Sir, please, your voice is not clear.
okay, thank you.
Something is obstructing your mic.
Okay. Let me see what I can do about that. Hello, is it better now? Chica, any difference
Yes,
at
sir.
all?
Yes, sir. A little bit.
A little bit. Okay, let me try and keep up louder. So we have the memory management information. You can see the information of the page table, and we'll speak about paging later in this class. Paging and how it works and the advantages of it. Um, Partitions, segmenting table, depending on the memory that you're using in your paging, and accounting information, and as well as input output status information, and a lot of other information like the PCB um, holes in its data structure. The PCB basically tells us um, the you can call it a little kind of database for information regarding different processes um, and managed by your operating system. So going into memory management now, so that an operating system performs memory management, which involves managing the primary memory, moving processes to the primary memory for execution and moving it back to the disk, moving it between the primary memory and the secondary memory. Because a program, a process, the program has to be loaded into the main for it to be executed, right? But the main memory can't hold all the data on a process. So it needs to also work through the secondary memory. And there needs to be some processes that needs to handle moving between the main memory and secondary memory, keeping track of how much space is available for allocation of processes in the main memory, how much is free, how this allocation is done, what algorithms are used to manage the loading into different spaces on the memory block. And this is done by the operating system. This logical process is carried out by the operating system. So, and it's memory management. So, thinking the importance of memory management, we have that the allocation and the allocation of memory before and after process execution. So when it's executed, so when a process is to be executed, it needs to be allocated memory space. When it is done with this execution, it needs to be deallocated from that particular memory space, that memory address, so that other processes, it needs to be done without plugging up the memory, without causing virtualization of data. It has to be done in the simplest and efficient way. So memory management, how it is carried out on the system, is important to how the performance of the system, entire system is in general, in regards to how it handles memory and how it handles data.
So, sorry to
Secondly,
interrupt.
to keep track of the
The audio
memory.
is very, very, the audio is very, very, very poor, honestly.
Okay, who else is experiencing this? Hello, who else is experiencing this?
I. It seems something is obstructing your
Okay.
mic.
Same here too. I think your mic is far from your.
Okay, have you been able to get anything from what I've been saying? Or you've not heard anything at all?
When you increase your voice, it's always clear. But when he starts speaking, then it goes back to being obstructed.
Okay, hold on a bit. Okay, hello guys. Is there any difference? Is there any difference? I tried to move to a different location to see whether anything will change.
It's a bit clearer now, sir.
Yeah, this is better.
A bit. Ah, so the difference isn't much at all.
The thing
Well,
is, anytime you clear your voice, it's always
Anyway,
better.
as
But when you continue speaking, it goes back. So
okay, I'll be looking in the chats. Just be dropping your feedback as we go on how whether you can hear me or not, so that we wouldn't go too far and you wouldn't hear me. Okay, so the importance of the importance of memory management. Did we hear what I said about allocation and the allocation of
Yes, your screen
processes
is not
during execution?
visible.
Did anybody get that? Did anybody hear? Thank you, Nisa. Did anybody hear what I said about allocation and the allocation of memory before and after I said?
Yes.
Okay. Okay, good. So next up, we have keeping track of the memory space by processes. Under memory management, you see that of the memory space being used by processes. That's how much is available to handle more processes. And whether the process it is loading can be fit into the particular memory space that it wants to load it into. They need to keep track of the available space and the used space and the free space, so it knows how to allocate the data. Because it can't, if it has only a space of 3 megabytes available, it can't be trying to load a process that would dynamically need like 4 MB. So it needs to be able to keep track of the space used by the processes. Minimize issues caused by fragmentation. We will speak more on fragmentation, but basically fragmentation is a situation in memory where you have available space in your memory, but that available space is in fragments and can't be used by, it's in different locations and can't be used by it can be used by the processes that need to be loaded into the memory because it's not concurrent, right? That might make a little sense. If it does, just hold it. We'll speak more about fragmentation later. So memory management enables us to properly utilize and efficiently utilize our main memory, right? Because without proper memory management, allocation and deallocation, without properly allocating and deallocating, without properly keeping track of the memory space available and what's available, without having processes caused by fragmentation, you see that you're not efficiently utilizing your memory. You can have you're not efficiently using all of it, but yet it's free. So that could be an issue that you can experience. And for data integrity while executing processes, this is to make sure that a process isn't causing inconsistency in data, causing inconsistency in those files, maybe writing to a file or reading from an outdated version of a file. Right? So maintaining data integrity is also one of the properties and importance of. Okay, so let us keep this picture in mind as we go on. This is how a logical address relates to a physical address. So when working with a process, what the CPU, what the processor sees is a logical address, a virtual address. It's not the particular physical address that the process is being loaded into in the physical memory. This helps with efficiency of the process. So a logical address or a virtual address is an address that is generated by the CPU for a process during its execution. It is the address that the process references, the address that process sees, and it is a relative address to what is actually what the program, what the process has actually been allocated as its address. Processor accesses the address, the logical address on the main memory, but then that is now translated. That's now translated through the relocation register, the MMU, inside the main physical address. Now, how this is an advantage is that the doesn't use absolute addresses. So if there is a situation for some reason that the main memory needs to change the location of a process of state card to move it to a smaller space. So just change the address. It can do that without the CPU referencing a wrong address. So but the logical address can remain the same, but the exact physical address can be changed, can be different. I hope that makes sense. So the physical address is now the actual address on the main memory where the data for the process, where the process and the data is stored. The physical address uses the memory management units, that's the MMU, to translate the logical address into the physical address and makes that available to the processor. So while referencing a process address space, the user, the CPU, the processor uses the logical address instead of the physical address. And this logical address is then translated into the physical address on the physical memory. So the CPU doesn't need to have an exact idea of where on the main memory the process is stored. It just needs to take account of the logical address. And this separation helps with the efficiency managing the process data on the main memory. So what is the MMU? The MMU is now the memory management unit, which helps in managing the translation of the logical address to the physical address for the main memory. It is usually found inside the CPU, or if there's a unit, a secondary processor, it can be found there as well. But it's inside the processor, and it helps with translating from the logical memory to the physical memory. It caches the locations it caches the physical locations of the processes in itself. So when a logical address is referenced, the MMU then checks its table and gets the physical address and does the translation. Or it can use a paging table if it's a situation where the addresses are too much to be cached inside the MMU, because inside the processor it can use a separate paging table for its referencing. We're going into computer science stuff, but it's important to know and have an idea of these things, so that when you're working with, even in a containerized environment, so you're even working in a server, you can understand how the CPU handles processes and how the memory handles data. Having an idea of that, even a little idea, can help you in how you configure your servers. Okay. So looking into static and dynamic loading. Static loading is a situation where a process, remember we said that a program needs to be loaded into the main memory for it to run. So with static loading, the entire program, the entire process is loaded into the memory for it to run. But with dynamic loading, the process is the data and the process, all the processing the data is loaded into the physical memory for execution, but it does so dynamically. Depending on the size of the process, it's able to allocate the data using different algorithms to make sure that it doesn't load all the data at once, but it loads the data that is needed while still being able to reference data as it goes along. Okay, so it says that so a program can be broken down into different processes. Remember when we spoke about having child processes to a particular process, you can have different child processes, which can be known as routines or subroutines of a particular process. So when a process has these different child processes, dynamic loading can load only the processes that are needed at a particular point in time, while keeping a reference to the other processes, the other routines, the other smaller processes, the other smaller tasks that are needed, keeping a reference to them and loading them when they are needed and deallocating them after they're not needed anymore. Instead of loading the full thing into the memory and maybe causing inefficiency and performance from the memory. So, and how insensitive it can be on RAM. So instead of loading the entire package onto your memory, dynamic loading can enable the CPU and enable the memory to load processes in small routines as they are needed. So linking, this is how different processes, different program, a program as a text file or not a text file, as a file is compiled into a packaged executable file, which is then run as a program. So a linker, we're going to look at static linking and dynamic linking. Right? A linker is a program that works with the compiler to create and combine all the executables into a single packaged file. Hello, can we all still hear me? I need some feedback in the chat. Okay. And we can understand what I'm saying. Okay. Okay, so we see with linking is similar to loading, where we have static linking running and packaging with 6M libraries, the entire program as a single executable and combining them all at once. Meanwhile, with dynamic linking, it packages the code in smaller bits for its execution. Right. So these are just some processes, static linking and dynamic linking, that are used in memory management to create more efficient execution of code and loading in the memory. Okay. So swapping is another concept under memory management. Looking at processes in the primary memory and processes in the secondary memory. You can have a process that is running in the memory that is being executed, and a secondary process, another process that is in secondary memory. Now, in a situation where a processor sees that there is a priority to another process, it needs a way to swap out one process for another one seamlessly. So swapping is the process by which the memory can switch out, can can take in a process from secondary memory into primary memory and bring a process from the primary memory into the secondary memory so that can execute a process with higher priority, or we can switch a process into the wait time while executing another process. Why swapping is important is that it needs a way to efficiently manage the data. Because if this process has already begun running, it doesn't stop the process. It needs to be able to still have the data on that process, execute another process, and bring in the other process to continue its execution. So quickly, when a process is executed in and resides on the main memory. Swapping is a process of swapping a process temporary into the secondary memory from the main memory, which is the first, which is like your disk, right? While you have your RAM, you still have your disk. Like moving the process from your RAM to your disk, bringing in another process, executing that and moving it back to your disk. So a quick illustration is this: you have a process running, which is of lower priority, and it's in your main memory, or you have a process that comes in which might have a higher priority, just for example. So swapping is the process by which the main memory is able to move one process to the secondary memory and bring in another process for execution by the processor. Okay. Let's keep following. Like I said, it's important to know these things. Sorry that I might be going too deep. So memory allocation. Let's try and bring all this together now. So memory allocation. How is a process given memory space for its execution on the memory, right? So it does that there are two different ways that process can be allocated memory in your primary memory. The first is the contiguous memory allocation, and then the non-contiguous memory allocation. In the contiguous memory allocation, you have, okay, first of all, looking at a memory, a memory can be broken down into various blocks, which are known as the various memory blocks in the code. So these blocks can be of various sizes depending on how the memory is configured. So your memory can have, for example, different sizes of 3 MB, 6 MB, 9 MB, just for example. Now, you want to load a process into this main memory. You can either load it, your full program, let's say your program is of 6 MB, and you have 3 megabytes blocks side by side. You can either load it into those 2 megabytes blocks sequentially, one after the other, right? Or you can, the main memory can look for any available block at any address on the memory and just load your different kind of codes. So that is the difference in contiguous memory allocation and non-contiguous. That's it, loading it concurrently or more randomly. So in the explanation, I say here that all of the available memory space reside in the same place together, which means that free and unused available memory partitions, you don't distribute the different processes randomly, but they are placed one after the other. That's the contiguous memory allocation. They are allocated one after the other, or they can be allocated more randomly. Let's use an illustration to demonstrate what we mean. So say you have a process and you have your different memory blocks. These different subroutines of different processes, let's say they are different processes now, or different subroutines of one process can be allocated into your memory block one after the other, right? Now, it can also be allocated in different positions in different addresses and locations on your memory block. Now, say a quick problem. Yes, let me finish explaining this. A quick problem that can happen is, say you have these different blocks, right, being allocated to the different blocks in your memory. You can create a situation where maybe your different memory blocks, you have 3 MB here, maybe 3 MB here, and also 3 MB here. And you have 2 MB here, 2 MB here. This can be allocated this space, right? But there'll be like 1 MB left of unused memory on that block. To now allocate this other subroutine or this other process, it can't fit into this available memory space, but it has to go into this other space and still leave 1 MB of unused space here. These places, right, of unused space are called fragments. And this is the fragmentation we're talking about, right? So you have available space, but this space cannot be used to run the processes. So say you have a process now, say you fill up all this space, you have processes chain, but the available locations are not contiguous. So they can't be used by these different processes. Does this make sense? Hello, Nuse. Nuse, question. Just quick, let's take one.
Yes, I'm with you, sir. Yeah, just a quick one, sir.
One
I
question.
kind of understand
Yes.
the explanation you are giving. I understand the explanation you are giving.
Mhm.
But mine is that what is really is this process? Is that it's like a command or a task? What exactly is this process we'll be talking about?
Okay. A process is a running program, a program in execution. When you write your computer code, print hello world, right? Hello world. So hello world, as it is written, is it's a file. It's a file. It's a .file. It's a .jar file. It needs to run on your computer. So it needs to be, when it's running, it is known as a process. That process needs to be allocated memory. It needs to be loaded into your RAM for it to be for the logic, the different instructions that you've written in your code to be executed, right? So say a process, when you talk about process, we are speaking to an executed program. Does it make sense? Okay.
Yeah, it makes sense, sir. It makes sense, sir. Sorry, I didn't get what you were trying to explain at the end there with those 1 MB remaining there. You were trying to say, okay, the 1 MB, what really happens? My network was glitching.
Okay. I'll come back to it later. I was trying to explain fragmentation. I'll come back when we get to fragmentation. I'll come back to this page. Okay.
Okay, sir. Okay, sir.
Okay. Okay. So moving on. Okay. So moving on. Fragmentation. Quickly into fragmentation. You see that when a process is loaded and removed after its execution, it can create let's say 3 holes, right, in your processor. Now these holes cannot be assigned to new processes because they're not combined. They're not combined to fulfill the requirements of the process. Like you remember I was saying this process requires like it's allocated memory. It requires for it to run, say 2 MB, right? And the available space is say 1 MB. It won't be able to run, right? So this problem creates fragmentation. In order to reduce waste of a process and improve the efficiency, the performance of the memory, you need to reduce fragmentation problems as much as possible. You need like when it says this space is used, this amount of space is used, you need to show that that amount of space is actually being used so that you don't have your memory at its full utilization, right? And there are still fragmentations, there are still holes that are in the memory but are not being used. So we have internal fragmentation and external fragmentation. Internal fragmentation, it occurs when memory blocks are allocated to processes more than the required size. When you have memory blocks of 3 MB being allocated to processes of 2 MB, for instance. This this is where what now creates all the leftover space and creating fragmentation. In external fragmentation, you have a free memory block, but it cannot assign to processes because the blocks are not contiguous. You have free memory blocks, right? But this cannot be assigned to processes because they're not in the same place. They're not contiguous. Contiguous means that it's one after the other. The locations are not simultaneous, right? So now paging. This is what can be the solution to fragmentation. Paging is a memory management scheme that is used to eliminate the need for contiguous memory allocation. Without paging, you will need to be allocating your memory to your processes sequentially. Let me say sequentially in a contiguous manner. This is the available space. This is the last space that was used. We are using the next space. This is the space that was used. We are now using the next space. But this space cannot contain this, that it's too small for the required process. So we have to move to a different space altogether. In order to solve that fragmentation problem, you need to be able to allocate your memory without needing to be contiguous about your allocation, right? So fragmentation is the process of retrieving processes in the form of pages from secondary storage in the main memory. The basic purpose is to separate each procedure into different pages. Additionally, frames will be used to split the main memory. So what this is saying is that you have, you remember I spoke about the MMU. The MMU implements paging. It creates instead of having contiguous memory, the logical address can be separated and then transformed into the physical address of the memory. Okay, I'll take questions later so I can follow what I'm saying. So paging creates this process where you can reference different locations on the memory depending on your requirements of your process. You can reference different places on the memory. And this is held, these locations are held in either the MMU or the secondary storage for the translation from the logical address to the physical address. It's held in the MMU. And with this, you can allocate space in a non-contiguous manner. Okay, let me look at some of the questions at this point. Hello, Chika.
Sir?
Yeah, I see there's a question you have.
Yeah, someone have answered, and I've used ChatGPT to understand what process is.
Okay.
Yeah,
Okay,
I
that's fine.
understand that is a process. Process is a computer program that is currently running.
Okay.
So it's clearer now. Thank you.
Yes, and it needs to be allocated a particular space in your main memory for it to run. Right?
Yeah.
How it is
Yeah.
allocated that space can affect the performance of the program, of the system it's running on. Okay.
Okay, thank you.
All right. Okay, can we go into Linux now? Is everything clear from this point? Hello, guys. Are we all still here? Lucy.
Yes, I am here. I am here. And I believe practical will help us understand the theory.
Okay. All right.
So
So
you said
moving
you would.
into Linux, the second part of. Yes, yes. Go ahead, Lucy.
Yeah, you said you say what happens to the remaining 11 MB, something like that.
Okay. Hold on.
That's from the diagram, what you were trying to explain then. You said, for example, 1 MB will remain in each of those memory blocks there. Something like that.
Okay. So what I was explaining is with contiguous allocation, right? You will need to be allocating it one space after the other. When you go into non-contiguous allocation, you can allocate in different available spaces depending on its requirements. And you don't need to be trying to fit it into. So when it now needs to be referenced from the processor, when it needs to be referenced from the processor, it uses a logical reference, a logical address for the processor, and that is translated into a physical address using the concept of paging. So, in out the need for contiguous allocation, you can be able to better utilize the spaces, the different spaces on your memory, including the little 1 MB, the 3 MB, you know. The next thing you can use, another concept that can be used to be more efficient when working with memory management can be the dynamic loading. So with dynamic loading, let's say you have this 2 MB, right? You have this 2 MB process. 2 MB process. You have 3 MB here. And say this 2 MB has now gone into 2 MB here. And you have 1 MB left, right? Say you use dynamic loading. You might not need to load the entire process, but you can. You can what? You can do 1-1. And with your pointer to the parent process, you can always reference it. We've talked about, so with this now, we've spoken about how many things. We spoke about, oh my goodness, how am I going back? We spoke about dynamic loading. Remember at the beginning, we also talked about the pointers and process counters, which can reference the parent process and reference the next address. So implementing some of this memory management concepts like dynamic loading instead of static loading that needs you to load the entire process into your memory. Implementing dynamic linking, implementing a non-continuous memory allocation scheme, along with the use of logical addresses and translations using your LME. You can better utilize your memory. Does it make sense? Did I answer the question? Say we are looking for how to efficiently use our memory. How does the operating system manage memory in an efficient manner? Hello.
Is that a
Lucy.
question, sir? Yeah, dynamic loading, sir.
Dynamic loading, dynamic linking, non-communication, paging. And do you understand? Okay. It's something that you need to keep studying and keep revising to keep knowing it. But I will take. Let me take another question. Is there any other question on this? Hello. Okay, Nick. Let me hear that.
Okay, sir. Just to be clear, so the issues we have with fragmentation is solved by paging or with paging.
The issue you have with
The
fragmentation.
challenges of fragmentation
Mhm.
is solved
They arise when
by
you're trying to.
using paging.
The issues that you get from
I
the issue
get
that
to
you get
understand
from
that fragmentation is a problem that we don't want. It's an unwanted
yes,
occurrence.
and exactly. And you see that occurrence when you're trying to work with contiguous allocation. You're trying to work with static loading. That is trying to load the whole program one after the other. So when you're implementing strategies, like when you're not you, when your operating system is working with strategies like paging, and it's working with strategies like non-contiguous allocation, and non-contiguous allocations can work only when you have paging being implemented using your NLA. You can now use your non-contiguous allocation. You can also use your dynamic loading, dynamic linking. So be able to put in your, like somebody asked, what do you do if you have a 1 MB application? What if you have a routine, not a part um, of a whole process that just needs 1 MB to run? You can put that part into that your 1 MB available space for it to run there using dynamic linking, because you don't need to load the whole process into that space. Does that make sense? Yes, Nick. Yes, Nick. I think you can say that to make use of it. Yeah, you need to use paging on your own. This is how this is already implemented for you by your operating system. Okay, it's just something I need to understand. I need to know about. Okay, let's go into Linux. One more question. Yes, yes. The process under memory management that is done by your operating system. Your operating system implements various. Remember, we talked about the various services, various operations that your operating system does in our last class. We talked about memory management, device management. Okay. Hello, are we all still here?
Yes, sir, we are
Yes,
here.
yes, yes.
Okay. Sorry, I got disconnected. Okay. Linux part 2. In Linux part 2, we're going to look at user management. We're going to look at group management. We're going to look at file permissions. We're going to look at process control commands. Okay. So User management. So in Linux is basically an operating system that can be used by various users, just like you have in your Windows environment. You can create a user for admin, then you can create other users on the same computer. That's the same way Linux works. So there can be different users on your Linux server. Your Linux operating system can handle multiple users. Now, these different users need to be able to have their own privacy and confidentiality. Another user shouldn't be able to read confidential files in another user's environment, right? So these permissions, this level of privilege, this security of users is handled under user management. Handling different users together, you need to create a group for them, a group of users, and manage their access together. So user management, group management, assigning permissions to them, handling their security, the security and confidentiality, integrity of their data. It's all processes and activities under user management and group management. So I say user is basically an entity in a Linux operating system that has the ability to manipulate files and perform various activities and various operations on the system, within his environment, or depending on another person's environment, within a Linux operating system environment. Now, a user needs to have certain data allocated to it. It needs to have certain properties allocated to it as its own. It needs to have a username, it needs to have its own password. It needs to have a user ID and a group ID allocated to it. It needs to have its own files within its own home directory. So if you go to the home directory, you will see different different users' home directories. So then you also need your users to have their own shell and their own password. Okay. So some user management commands. I hope we'll have some time after the class to go through these commands. All your users are saved to a directory in etcd, in the etcd folder called password directory. That's the directory you can use to see all your users. Remember, the cat command is used to print things onto your terminal. So to see all the users and list all the users in your computer system, you cut out the etcd password file. To see details on the user, use ID user. Say you create a user called Chika. You can do ID Chika to see all the details of that user. To create a new user, use the command user add. Your sudo command is your super user command, right? It's used when you need to perform actions that need admin privileges. So when you do your sudo command, it will ask you for a password. You put in your password. If you're part of the sudoers, if you're part of the admin users on a particular system, then you can have the access to execute certain commands. So you have the ability to add users, you have the ability to change the user's password. You can modify users using the user mod command. If you're working with a group, you use the group mod to modify the details of a particular user. Maybe you want to change the user's name, you want to change the user password, you want to change the group that the user belongs to, the primary group, or you want to add a user to a particular group. use the user mod. To delete a user, you use the user delete command. And to add a user to a group, use the group add. To delete a user from the group, use the group password delete. So these are some of the commands under user management. Under group management, you have similar commands. You have the group add to create a new group. To add a user to a group, you see you can use user mod add group user. That's the last one we have here, number 7. To add a user to the group. To view the groups, because groups, when you create a group, it is saved in the etc group folder. Who can remind us what the etc folder is?
The etc folder is a folder that houses the configuration files in Linux.
Okay, excellent. So you see what's happened there. So when you configure a new user or a new group, the data for that user and that group is saved in your configuration folder, which is your etc. Who answered the question? I'm owing somebody something.
It's me, sir.
Emmanuel.
Yes, sir.
I'm owing somebody something. I've forgotten the person. Okay, moving on, you have the group mod. To modify details of a particular group. Want to change the group ID, you can use group mod, new ID, create a new ID for the group. If you want to change the group name, you can also use group mod. If you want to delete a group, use the group delete. And there are many other commands you can use to manage groups and manage users. Nice. So going on to file permissions now. In our last class, somebody was talking about the change mod plus X, right? So we're going to talk about that now in file permissions and file management. So when you come to file permissions, you have 3 important groups that are handled for a file. You have the users, you have all the users in the system. You have groups and you have owners of a file. If I create a file, I am the owner of that file. Then there's a group that can own that file, right? If I want an entire group of maybe business analysts to have access to financial reports file, maybe I don't want the software engineer group to have access to, to have access to this particular financial budgets file, financial expenditure file. I can give only a particular group read access to a file, right? I can decide to give a particular group read access and write access to a file. I can decide to give another group only read access so that they will not be able to make changes to the file, right? The same I can do with users, and same thing I can do with everybody else system-wide on a particular Linux operating system, Linux server. So with that, we have different file permissions that a file can have. We have the read, which is R, to read the file content. You have the write, you have the execute, and different symbols when you're specifying file permissions. You can add permissions with the plus. You can remove permissions with your minus. You can set specific permissions, right? If you want to say you want to add write access to a particular user or a particular group, you can do add with the plus R to add write access. But if you want to, if it already has write access and you want to change the access to only write and execute, if it already has read access and you want to change the execution to maybe write and execute, you can use the equal to symbol to change it to the specific type of command, the specific type of permissions that you want, instead of just adding or removing. So users, now you have the user, which which when you use you're referring to the giving users a user permission, and it applies the permission to the owner of the file, and it's not impact other users. You can add permissions to a particular group of users, and it should affect the users within that group, and it's not affect users outside that group. Now, the others, and the others, this affects both people within the group and outside the group, right? No, sorry, it affects people outside the group, right? If you have a file assigned to a particular group, you can also set the permissions for people outside that group, what kind of permissions they should have. Maybe you want people in the business department, the business group, to have read and write access to a particular financial report file. But you also want people outside that group to be able to read the file, even if they're not able to make modifications to it, like by writing. So you can give other people read access, but give only this group read and write access, right? Now, if you want to add permissions across board to everybody, you can use the A value, which give access to all three groups, which include the users, the groups, and the others. Now, what does this mean? What am I saying? Right? How is this applied? Okay. So I'm sure we all know how to convert decimals to binaries, because this will come in handy later. Is there anybody that doesn't know about this?
Yeah, so last
No.
time I did it was 20 years ago.
Okay, so converting to binary. We are not going to go into that, but we can simply just know that you can get a table for converting to binary. There's a decimal value can have a reference, because our computers only understand zeros and ones. So you can convert a particular number to a binary, right? There's some calculations that multiplying it by or dividing by 2 as well. I am missing some slides here. Sorry. Okay. So the change mode command, some of the examples we were talking about before, the change mode command is used, like we said, it's used to change the permissions on a particular file, to change the permissions maybe from execute to write only. You can use the change mode command. Does anyone remember when we talked about the change mode command in last class?
Yes, sir.
Okay, so you can use the change mode command to change the permissions on a file. Now assume we have a file called xyz.txt. You can use the change mode command to change the permissions on that particular file. Now, let us take a few steps back. Okay, remember we talked about this U, which represents the user. We have G, represents a group associated with a file, and we have the O associated with everybody else outside that group. Again, you have the user, which is the owner of the file, the group, which is associated with the file, and everyone else, which is there. Okay. Now, assuming you want to add executions permissions to the other group, that is everybody outside the group associated with the file. We have X as execute, and we have plus as add permission, right? And you have O as the order. That's what we have as chmod plus X. That is add permissions, add execution permissions to everyone outside this file for the XYZ file. Is there anyone that does not understand why this is, so that I can explain it again? I'm looking at the chat now. Is there anyone that doesn't understand it?
Please kindly explain again, sir. Please.
I think it's important that I go into the terminal. Just give me a moment. Let me try and open my terminal so that I'm using both of them. Right? Would that be better? Okay. Okay, that's fine. Let's go into the terminal. Okay. Can we all see my screen? Hello?
Yes.
Yes.
Okay.
Yeah, it's visible.
You can still see my screen?
Yes, the
Yes,
black
Yes.
terminal.
you can see. You can see each other.
Okay, so this is the folder we were in the last time. And we have when going to access files. Okay. So let's look at these files now. Right. We have you see these 9 characters here. You have RW, you have R, you have R, you have RW, you have R, you have R. Right. If we come here, you see where we looked at this, right? You have these 3 groups. You have the first group, which refers to the user. You have the second group, which refers to the group that the user belongs to. And then you have the last group for others. And these 3, right, can have different permissions for the particular file. So here we have the first one for the user. Who can tell me what this access means?
It tells us that a user can read the file, can write, but cannot execute.
Excellent. Who was that? Emmanuel. Okay.
Yes, sir.
Yes. Yes. So you see that the user, who is the user? The first. We're looking at this first. Should I get my invitation? So yeah. So we are looking at this first part. Right. That's what we just saw. So this next part now, what permissions does it have for this file?
The second file is
Wait,
the
someone
group.
else. Please try. You see that this next one has for the group. Go ahead. Okay, go ahead, thank God. You see that this one has
Second part only has a
R.
read out without
writing and execution.
Okay. Now, for everybody else, that is for others, you see that they have only rights. They have only the power to write. Now, let me go into the illustration. Let's see the illustration. Now I said, who asked that question? Chika said she doesn't understand what this XYZ file was. So that can just be, that's just an example of it. See, here now we have test file, this one. So let's create our XYZ file. What's the command for creating the file? Chika, were you in the last class?
So yes, I was in the last class. I think to create
What's
a
the command
file
for
is
creating?
touch, and then
Okay.
file name. So please, can you zoom
So
your this thing very well? The terminal. It's too
okay.
far away. Thank you.
Are we good? Is it too big?
It's okay. It's okay. Thank you, sir.
Okay. So, okay, we're trying to create that XYZ file. Okay. And if we list it out now, see that our XYZ file has the same informations. Read and write for the user. Only read for the group. And you see there's a minus here. So let us see what that minus is doing. So we're going to let's create a directory, right? Just quickly so that we can move. So very quickly, you see that that's when there's a directory, when it's a directory that's relations, there will be a D at the beginning. When it's just a file, there will be no D there. So I just wanted to say that. And in this directory, users will be able to execute users. That is me. I'm the user. I'm the owner. So as the owner, I'll be able to read, write, and execute everything in that directory. That can be overwritten by the file itself when you're going to deploy it. Okay, ask a question.
Hello, can you hear
Okay,
me?
sir. I actually requested for biological break, so I stepped out to use myself and came back, and everything is now looking like Indian film to me now. Yeah, so, but I don't understand how
You have to.
with the permissions now. I know I was hearing you say this person had permission to read and write, but cannot read and all that. And that's when I stepped out, and I don't know how that factor came in, how you were able to determine what somebody can do, a user can do by merely looking at this.
So we have different permission groups. We have the users, you have the groups, the user or the owner of the file, you have the user, you have the group that is associated with that file, and then you have everybody else, right? These three. So if I look at a file, if I list, I just see the files. But if I list, see everything, I can see these three different things here. You see, you have ignore this first dash. You're looking at this one, those three permissions belong to the user, the owner of the file. This next three belong to the group. This last three belong to others.
Okay.
Right? So we see that the user has permissions to read it, but can't execute this file. Because that is not an executable file. We also see that the group has only permissions to read, but cannot write or execute. And everybody else has permission to read as well. So let's look at this ch mode 0 O, that's others plus X. Let's see that for XYZ file. So you have others. We're adding execution for XYZ. So this was what we had the last time for XYZ. Read only. So now we have changed it to be able to execute for others. If I want to also be able to execute the file as the user on the file, I can do ch mode. What should I use here? Somebody different should just tell me, someone who hasn't spoken before. Who will tell me? Adedeji, you're here. You're just be quiet throughout.
I'm here, sir.
What should I use here? I'm trying to add execution privileges.
The question again, sir.
Okay. You see that we have the user permissions as read and write. Is that right?
Yes, sir.
What is the group permissions?
Read.
Okay. And what is the permissions for others?
Read also. Read and execute. Read and
Read and
execute.
execute. Now
Yeah.
I want to add execution permissions to the user. How do
Okay.
I do that?
Yeah,
mode works.
No, I think to every other one, you use
Now to the user.
to the user U plus X, I believe.
Okay.
Or O plus X, I believe. O plus X.
X.
Yes, I think.
Okay. Then what else?
Touch.
Touch.
Okay, no. The file is XYZ. No,
Okay.
XYZ the text. Yes.
Okay. So if I execute this
Yeah.
adding execution permissions to O is or
Okay.
that's here. I'm sorry, these permissions to the user. That is to the owner. That's the first one. So I can use O. What should I use?
Okay, should be you then. I believe.
Hmm?
It should be you.
To be you. Okay.
Yeah.
So we're adding execution permissions to the user. You. Okay, okay, so now we see that the user also has execution permissions. Now I want to remove this execution permissions from others. I don't want them to be able to be execute this file. Chica, what should I do?
Okay, you use chmod, chmod, then others, right? O minus X, then the file name.
Okay. So that's correct. And let's remove those permissions there. Right. Let's just do the same for the user. Okay. So we see that. Thank God. Thank God. Hello, thank God.
Yeah, I can hear you.
I want the group to have write and execute permissions on this XYZ file. What should I write?
Sorry, I didn't get you.
Okay. We see that the group right now, they have read permissions already. I want them to have write and execute permissions. I don't want them to have read. I just want them to be able to write to the file and execute it. Does that make
You only
sense?
want them to write and execute.
Just write and execute permissions.
So we are removing the read permission and adding write and execute.
Yes. How do I do that? With one command.
So chmod
Okay.
G minus R.
With one command. Okay. Minus R. Okay.
With one command. I'm not sure. But
Okay.
anyways, I think we can just write everything together like G minus R, then G plus WX,
Okay.
then the file name. I'm
Oh,
not sure if that
XYZ.
will work.
Wait. We will try it now. Okay.
Oh shit.
Okay, so the problem here is that it expects the file name immediately after you've given the permissions.
Okay.
So it's saying that there's no directory like this. So we need to do this with one command, one execution command. I saw your hand up. I remember the person who just put your hand up again. Okay, well, let's hear from you.
Actually,
Thank you,
I'm
Tango.
requesting for you to repeat the question. I didn't get the question properly.
Okay, so you see that on this file, the group. Let me just remove this. So you see that. Oh, okay. Okay. So we see that on this XYZ file, the group has only read permissions, right? I want to give this group write and execution permissions only. I don't want it to have read permissions again. In one command, how do I do that?
Okay.
Hmm?
In one command, you want to give write and execution permission to
Yeah.
chmod. Don't know if it's going to be right, but let me just try.
Mhm.
I'm coming now.
What are
Add
you
your
doing?
you add your
No chat
plus sign there.
GPT.
I'm not using
Okay.
ChatGPT, don't worry. You're
Okay.
safe.
Plus sign.
Then how do you even write it again, Seth? So
It's
there
not
is
specified whether it's the group or the user or not. Hold on.
specifies the group. We use the G.
Okay. So you put the G before it plus, correct?
And then W and X, I think.
Your XYZ.
Your XYZ file.
Okay. So let's see what we have.
This works.
Okay. So
Oh,
that still has the read permission. It's correct, but I wanted to. Hello, Dari. Go ahead.
Okay, I think it's going to be chmod, then G equals to
Okay.
RX. Should be read and
Right.
execute.
Write and execute.
Okay, so it's going to be G equals sign.
Okay.
So
UX.
write and execute WX. You said write and execute.
Yeah.
Yeah, okay, yes, WX.
XYZ,
Then
CXT.
not the file.
Okay.
Yes.
That's very correct. So we have changed it to a specific permissions, write and execute. Okay. Thank you for that, Dari. So that's what we were trying to do in one command. Okay. Now, why did we talk about the binary? Okay. We are looking for an easy way to write this, to do this notation. You can do it either with the letters, or you can use the octal notation. where you use numbers from 0 to 7 to specify your permission. 0 in the binary form will give you 0, 0, 0. So that is no permissions for them. 0 to all of them. 1, you can convert 1 to binary. So that is 1. So 0, 0, 1. That's giving executable permissions. Remember, we have this read, write, execute. So if I put 0 for read, 0 for write, and 1 for execute, that gives that particular permission group only X permission. If for the group, I put 0 for read, 0 for read, 1 for write, and 0 for X. I've given this only write permissions, but I can't write all these numbers. I can convert it to the decimal, which should be, I think this 3. I think that's 3. I'm not sure. But say the decimal value. This is the value we're using. Okay. Or say I want to give this only read permissions. That is 1, 0, 0. 1, 0, 0 is number 4. Correct? Let's check. Let's check. But do we understand what I'm doing with these zeros and 1? You have read, write, execute.
No.
You don't understand. Okay. Let's look at it like this. Whichever you use 1. Let's use 1s and 0s. We know that 0 means off and 1 means on, right? Does everybody know that? Logic gates. Does everybody know 0 means no, 1 means yes, 0 means false, 1 means true? Hello, Wogo.
Yes, that's what they said in computer.
So what the computer understands, if you're looking at anything digital technology, in fact, your light switch, if you're switching something on and off, you see that there's a 1 up and a 0 down. Has anybody seen that kind of thing before?
Yes.
Yes.
Yes. Okay. So we have let's write in this instance. We have R. We have R, right? We have W. We have X. ADDG, please put on your microphone. Right. Just look at me. Are you there?
I'm with you, sir.
Okay. So what is R?
Read.
Okay. What is W?
Right.
Okay. What's X?
Execute.
Execute for a file. And this, remember, it's available. It specifies permissions for all the groups, all the permission groups. You have it for user, you have it for group, you have it for others, right? RWX. So say R is false, W is false, and your execution is true, right?
Yes.
So that's where you get the 0, 0, 1 from.
Okay.
First person that didn't understand is 0, 0, 1.
But your so
Do you understand this?
no, not yet.
It's
Hello?
clear now. No.
Okay.
It's not yet clear. I understand to read, write, execute, but why are they labeled as 001?
Okay. Say on a file now.
Okay.
On this particular file, there is only read permissions on this file. Who is that? Adekoya. You're in a noisy environment.
Yes, yes.
Okay. Okay. Okay, I can hear you. Keep your mic open. Can you hear me?
I can hear
Yes,
you.
I can.
Okay. Don't let me talk to Adekoya. Adekoya, you can mute. Let me talk to Adekoya. So, Adekoya, on this particular file, for my user, I want my user to have only write permissions. Keep in mind that 0 means false, 1 means true. And I want this user to have only write permissions. I want this user to have only write permissions. What will my read be? Is it false or true?
Okay, it will be false. 0.
0. What will the write be? It's true.
1.
I want
True.
it to have write permissions. It will be 1. And the execute?
0.
Okay, it will be 0.
Yes.
Okay. This notation is binary. I want it to be in decimal. What number will I use?
In decimal?
Say it. Yes, in decimal. What number will I use?
To present in decimal.
Yeah.
I did not get your question.
This 010 is a number. It's a binary number. What is its equivalent in decimal?
Okay, open it.
Hello, Adekoya, are you still with me?
Yes, I'm here.
Did you hear the question?
Yes, I heard your question.
Okay. Do you want to call someone
Yeah,
else to answer?
that should be 2. That should be 2.
Okay. So that is 2. So that is 2. So that's all this table is saying here. That's all this table is saying. Then you have. Okay, thank you, Adekoya. Thank you for that. Is it clear now?
Yes. It's clear to this point. I didn't know that's what you did.
Right. Yeah.
Thank
Right,
you.
you can mute now. You can mute. Thank you. Thank God.
Yeah,
Thank
I
God.
have a question.
Okay.
Okay, so with regards to the question you asked me, we got the answer to be G equal to WX and then defining. But from what I'm seeing on your screen right now, I think we can also use commas to, so like, can we go like G minus R, comma, G plus WX, then defining? Does that work?
Okay. We'll find out now. So we have, let us okay. So what did you say?
I said, okay, chmod G minus R,
Okay.
comma, G plus WX.
I think this might work.
X.text.
Okay, that works as well. So you can also use that method.
Okay.
Okay. Yeah. So what we did before was we used space. So instead of using space, you can just use comma. And that works too. Okay. Okay. So yeah. So these different numbers, using their binary, give either true or false values to the different permissions: read, write, execute. So now, okay, it's almost 8 o'clock. So now, let's try to. We have user, we have group, and we have others. for this file. I want everybody to have read and write permissions apart from others. So I want user and group to have read and write permissions. Okay, no, let me change that. I want the user to have read, write, and edit permissions. I want the group to have read and write permissions, and I want others to have just read permissions. So with the normal notation, that should be change mode. We have user. We can do plus, but let's better understand. Let's use equal to read, write, execute for user. We want the group to be read and write, and we want others to just be read. Let's change. We want others to be just execute. Okay, just read and execute for XYZ file. For the XYZ file. Is everybody following me?
Yes, sir, I
Hello,
am.
Chika. Yeah. Okay, Chika. Okay,
Sir?
leave the mic open. Leave the mic open. So we want to change this user to read, write, and execute. We want to change the group to read, write, and we want the others to be RX, that is read and execute. This is a relatively long command. I want to make it shorter, and I want to use the octal notation, right? So how will I do that? Chika, you see there?
Yes, I
Hello?
am here. I am
Okay.
here. So
Okay.
you want to use
So,
octal
yeah.
notation.
Mm-hmm.
For the U, you use 7.
Okay. So
For
let's
the
switch that up. Let's switch that to 7. 7. Okay. So for
yes,
read and write for group.
for read and write, you use 6. 7,
Okay.
6. You write them together, yes.
Mm-hmm. Mm-hmm.
And
7, 6, and we want R and X.
you want, what's the last one? R and what?
That's read and execute, right? R and X.
R X.
Yes.
That one we use 4. No, not 4.
Okay.
I'm not seeing RS though. Not
Mm.
seeing it on your file mode. But RX
Okay.
will now be, wait, just keep the binary. Let me check it out. The first one is read. The second one is write. The other one is
Mm-hmm.
execute. So RS should be 101.
Okay.
So 5.
Okay. Wonderful. So we have 765.
Yeah.
765.
Yes.
And let's look at that. So we see that that is very correct. We have the user having RWX, read writes execute permissions. You have the group having read and write permissions. You have. So thank you so much, Shika. That's excellent. Somebody here is not talking. Princess.
Even me, I'm not talking. No.
Lucy. Lucy, you're not talking. Ah,
I'm not talking.
that's
No.
serious.
I'm just looking
Lucy.
at this film here going on here.
Oh yeah, Lucy.
Sorry, let me get something.
Lucy.
Sorry, please, just to chip in.
It's
That
nice
table.
to have this
Are we
slide.
supposed to learn that table? Are we supposed to learn that table, like have it in our memory, something like that? Or you write it one side and keep it? Are we supposed to have this table in our head?
No. What should be in your head? What should be in your head is this, right? You should always know that every file will have read, write, and execute. Okay. Now read, write, and execute. Whatever it is, it will be either true or false for each of this. So this now needs to be converted to a decimal number. Okay. Hello? Does that make sense?
Yes, I'm with you, sir. It makes sense. Yeah.
So you don't need to memorize the full table. Over time, from secondary school months, I already know that I already know this system to be 0 is 0, 1 is 1, 2 is 1 0, 3 is 1 1, 4 is 1 0 0, 5 is 1 0 1. 6, I already know that, and some people already know that. Some people know to even 10. Some people actually have to convert it and do the calculations. You can simply just learn it maybe on Google or something like that. Or you can always Google for this, right? Sometimes you can even know that, okay, when I want only read permissions, I should use number 4, that kind of thing. But always do research. Don't be afraid to Google anything. That's something you should know about working in tech, programming, whatever. Don't be afraid to Google anything. Right? Okay. Thank God. Thank God. Question.
Okay, yeah. Another question. So I was wondering, if you give a file, if you give a group access to read and write on a file, right? And the user is also a member of that group. Does that user get those access as well? I don't know if you understood me.
I understand. Say your user has only read permissions, and then you give a
Yes.
group read and write permissions.
Yes.
Yes, the user will get these permissions. The user will get these permissions. How that affects list privilege now? You know what list privilege is?
Yeah, I do.
The concept
I
of
know
list
what it is.
privilege.
I know
Now,
what
how
it is.
that affects list privilege? It's a good thing. It's something that really poses a question, and a very interesting question. Okay, so a file can be associated. I think a file can be associated with a group that the owner might not be part of. So I can create a file for the business admin group, and I might not be part of that group. So users in that group, I might have read and write access to the file, but users in the group might have only read. That's a very interesting question. That's a very interesting question. Thank you, Tango.
Sir, please, I have a question.
Yeah.
But then I just got a eureka moment in understanding this table for my fellow people that maybe may not understand. See this binary, we have binary and we have file mode. When we have 0 in the entire place, it means a blank, which is that dash in the file mode area. The second item there, which is 001. That means the 0 and the 0 are blanks, which is the minus that is in the file mode. Then the last item there is 1. That will indicate what it's meant for. So you cascade that way. I think kind of sticks that way to me. But then my question is this: the examples we have here, assume file name is xyz.txt. That can you kind of explain? Let me explain what those commands are. This o plus x, ugo minus rw. Can you just kind of just a short explanation of what these examples are? What are those command lines actually? Just to give more clarity. Yes, sir.
Okay. So you have user groups, right?
Sir.
And you have different values that can be associated with those user groups. So you have your owners, the owner of the file, which is also the user. You have the groups, and you have others, which is everybody outside the group, and that's not the user. So you can specify them as U for the user, G for the group, and O for others. Then this plus is add permission. This minus is remove permission. Then the equal to is used when you want to specify a particular specific permission. So if this if a user has read and write access, and I want to include to that access, right, execution, I can use plus X. If the user has read and write access and I want to remove the write permission, I can use minus W. If he has read and write permission, and I want to change it to only execution permissions, I want to remove the read and write, I don't want it to only execute, I can use U equals to X, and that will change everything to X. It's remove the read and write permission, right? So for a quick explanation, we have O for others, O plus X, change mode O plus X for the XYZ file means add, this is add, this plus is add execution permissions for others. This is others here. This is others here, right? The last three. So you can see that when we list out these files, let's clear the screen. When we list out all the files, Lucy, are you with me?
Yes, sir, I'm with you, sir.
When we list out these files, you see that there are 3, 1, 2, 3. There are 9 permission groups. 1, 2, 3 is for what? Hello, Lucy.
With
Let's
you, sir.
communicate. Open your mic. Yeah.
I'm with you, sir.
So these first 3 commands are is for what? It's for which
for the user.
group? For
Let
the
me
user.
Yes, the user, yeah.
This next one is for what?
The group.
And the last one?
For others.
Okay. And this first one, this first dash.
Which first dash, please? Okay,
there's one dash here.
Yes, sir.
What is it for?
Honestly, I don't know.
Okay. Yeah, it's for D. It's for D. It just tells you that this is a directory. D, look at this last one.
Yeah, that's a directory. The last one
is a directory.
The other ones are files, yes.
Yes, so this D just says this is a directory.
Yes, sir.
Not a file. So when there's no D, there is no C file. Okay. So UGO means what? You say
the user. Yes. Okay, user group orders.
Now, minus means what?
We want to remove something.
You want to remove the permissions. And you're removing read, write, execute permissions.
Read, write, and execute permission. Yes, okay. Exactly. It's not hard now.
Okay. Let's do something. We have chmod UGO minus. Okay, let me add it first. UGO dash write execute. So then you have chmod UGO minus XWXYZ. Hello, Lucy.
With you, sir.
I want to convert this to the octal notation.
Okay.
How do I do it?
Okay. Let me go back there again. Okay. WX. WX is simple now. 011. It's not hard again.
Okay. It's 011. But remember, I'm not adding permissions. I'm removing. So I want to remove. You see that this is that file. UGO. I have added to the user and group write and execute permission. So everybody has read, write, execute permissions. Read, write,
yes,
execute
everybody.
Both I want to I want to remove write and execute permissions from all of them.
Okay.
Right? If I use this, you said I should use I should use 011.
Three.
That is
Yeah.
number 3.
Oh, 3. Yes, sir. Mm.
So that will look something like CH mode, right?
Yes, sir.
3 for user,
Yes, sir.
3 for group,
Yes, sir.
3 for write and execute
Yes,
on the
sir.
expensive file.
Yes, sir.
Okay.
Scam, now it work.
So this has it's WX for them. Does everybody get that?
Me, I'm safe now.
Somebody raised hand. Abdul Latif. Somebody's hand is up.
Yeah.
Abdul
Hello.
Latif.
Yeah.
Question
Hello.
or
Yeah. Question, sir. So what if
Okay.
we didn't specify maybe user group or others? Example, we just put plus X RW and the file name. What will happen? Or is it must that we specify the
Just use plus
maybe
RX.
just like plus X or plus R and the file name? What will happen without specifying whether group, user, or others?
Okay, so that affects everybody. You see it, sir. So if I do ch mod plus R, ch mod equal to R, right? On XYZ.
Hello, sir. I said not equal to, like plus R and the file name without specifying either group, user, or others.
What will happen
That's
is
what
that
that means.
it will affect everybody.
Oh,
Or
okay.
also
I
to
get.
affect everybody, I think you can use A
Okay, just
instead
to
of
affect
just
everybody, I was just
specifying.
putting. Okay, okay.
It's better instead of doing that. Instead of doing that, it's better to just use the UGO because I don't know. Best practices, let's just follow that instead of not putting anything at all. I don't think we can go beyond this. We'll have to move this the remaining. It's a short part remaining. We have to move it to our next class because it's already 10:8. And I mean, to prevent information overload, I think we'll just have to.
To prevent fragmentation, we can end here.
So we will have to. Is there anyone that doesn't understand CH mode commands? Is there anybody? Okay. Nick, do you understand?
Yes, boss. Clear is
Okay,
clear.
you get it. Okay.
Just that
Wonderful.
I'm thinking of refreshment going forward.
Refreshment. Like virtually.
No, from Michael and thank God.
Sir, please, I want to suggest something again. Some people don't like chatting or making comments here. It seems like some of them knows this more than us. Somebody sent to me that read it. Let's just take read as 4, write as 2, and execute as 1. If you can just remember these 3, will be fine. So I don't know if that suffices as well. Read 4, write 2, execute 1. If you can just remember those ones on our head, it will help.
Those are the ones that you see yourself interacting with, right? You will see yourself working with. Mostly you will be doing 4, 6, 7, maybe 2, and maybe 1. To give a file to give a group just write and execute. But it's better to just know all of them. But what that person might have been saying was what you mostly be working with. You get?
Okay, sir.
Yeah.
Please,
But
I want to
it's
ask
best to
questions.
use. Okay.
Can I ask a question? My question,
Yeah, go
because
ahead.
I see that this notation is only for hexadecimal, octal. Do we have anything for hexadecimal and the rest? Because it's not only octal we have here. But I can see that's only octal we have been using since. Do we have anything
I
related
think
to hexadecimal for this changing mode?
no. I think the octal just makes things easier. Basically, I think it just makes to make things easier. If you use hexadecimal, so I think it will make it more complicated than the normal. It can make it more complicated than the normal use of O and UGO and X and all of that. So being able to use decimal numbers that you understand, which now converts to binary that the computer understands, is the best way to go.
Okay, so this is the best way to work with it.
Yes, using the octal notation is the best way.
Okay,
If you
sir.
want to use the letters, well, you can go ahead, but if you have an easier way to do something, it's best to do that.
No, the letter as well is not like too hard. When you take 10 as A and you take 11 as B, T, F.
Yeah. All right. It's almost 8:15, so I think we're good. Yours will be the last question. Yeah, go ahead. Go ahead. Hello. Hello, Michael. Your hand is up.
Oh,
Okay.
okay.
That
Yeah,
was a mistake.
sure.
Okay.
No mistake. No mistake. I wanted modify. Okay, so yes, can you also make a directory executable too?
If you make a directory executable, you're making the files to the directory executable.
Or is it
Right?
something like
You
one?
can't execute a directory.
Yeah. Hello, can you hear me?
Yes, I can hear you. I can hear you. So making a folder executable doesn't necessarily the files don't necessarily inherit that permission, right? So um to make a folder, a directory executable, I don't think it makes much sense because you're trying to execute files, except you want to execute all the files in that directory. But then the executable permission they're not necessarily inherited by all the files in the directory. So you will need to specifically make the files executable.
Okay, noted.
Yeah. Or what would you have any different idea to that? Is there a reason you asked?
I was curious about it because I got to think about how compression really works when it comes to files. You know, when you compress your file into a zip file, then you now have to change the path to you have to extract the file from a zip file. How does the process go when it comes to extraction? So that's why I asked that question. Oh, I understand.
When you package a file, when you compress it, that is like packaging it into like an object. So if say you can execute that if you can execute that package file, you're executing a more like an object instead of just a directory. I think it's an interesting thing to look at things.
Okay.
Say if I compress a file into a .zip file, right? If I compress, like this folder is KD4. If I compress it, it should be something like KD.zip. That is now an object. That's now like a packaged artifact, a packaged object that can be probably executed. Right? But executing a folder, I'll have to think about that or research more on it. Executing a folder just like that, I don't know. But changing it and compressing it and turning it into more like an artifact here, that makes more sense. Hello, Wogo.
Yeah. Thank you very much for that.
All right. Thank you. Thank you for that question. That's an interesting one. All right. So thank you, everyone. We have not finished with these slides. We still have some more things on processes, handling processes and DevOps. We'll treat that in our next class before we go into the next class. Will just to be exclusively for vagrants and Linux and practicals, but we'll check this in as well. Then we go from there. Okay, is that fine? Because we're almost 20 minutes past it. Okay, sorry, I've kept everyone too long. Somebody's number. Okay, thank you everybody for coming today. Really appreciate the time. So I'll look forward to seeing everyone in the next class. All right.
Thank
Nobody
you
should
very
get
much.
Thank you, sir.
discouraged though.
No.
All right. Thank you.
We die
Have
here.
a great weekend. That's right.
And you, sir.
Princess, we did not hear your voice since it's now you're saying bye. But it's good to know you're in class. All right, everybody enjoy your weekend.
Should not be class today's class.
That's fine. That's fine. All right, everybody. See you in the next class. Have a wonderful weekend.
I have a question.
Bye.
Okay.
Let me stop the recording.
I have a question.
How do I stop recording? Okay. Okay. One last question. Last question. Who is that? Last question. Oh, can you drop it in the Discord channel? Drop it in the Discord channel.
Okay. I'll do that. So there'll be so many questions then.
Yes, no problem. All right. Thank you so much, everyone.
Thank you.
Bye.
All right. Good night.
Good night.